as you can see from, you have F21, 2 over 3, F31 minus 1 over 3. We are going to put them in those values, and then we form let me see. Let me see something here. Okay, so you put F21 here, F31 here, and F32. That forms the lower matrix. And if you multiply it with using the original B given, that's what we're trying to do. So you have D1 equals minus 10. You have the first equation is D1 plus 0D2 plus 0D3 equals minus 10. The second equation is 0.667 plus D times D1 plus D2 plus 0D3 equals 44. The next one is minus 0.333 D1 minus 0.18181 for D2 plus D3, 1 times D3 equals minus 2. So when you resolve these equations, let's see what we are having. We have D1 equals that, so we substitute D1 into the second equation. See, we substitute 10 here. 10 here, so it will be 6.667. If you move it to the other side, it will be minus. All right, it will be minus. So you can calculate G2. Let's look at it.
Yeah, it will be minus 6.667.
No, it's not minus, it's positive.
It will be minus
positive.
Minus 6, correct. Minus 6.6667.
Minus 6 to be plus. Yes.
So it will go here, it will be plus here.
Yeah, plus.
So it will be 50.
Now give us 50.
667.
In the way this original question.
It will be minus, right?
No,
it
it's
will be
minus because of the negative sign.
It will be minus or plus. Is it not plus?
It will be plus, sir.
It's plus. The right-hand side is
Negative
plus.
is crossing, then it becomes plus.
Okay.
So it will be added to 44.
Yes.
Yeah. So now, what we do is we know D1, we know D2. We can calculate D3. D1
is negative.
We can calculate from here. Let's calculate D1. So this will be positive.
Yeah.
D2 here times
Negative.
50 to be negative or positive. To be positive. It will be negative here, right? Right. Why this one will be positive? So it will be minus. It will be 3.33 something times 50 minus 50 times this. Right? If you carry this plus. If you carry this plus to this page to be minus 26 minus 3.333,
yes,
and plus, because since it will be minus here to go to this page plus.
Yeah.
So when you do that, let's see what we have.
It's minus 20.1210.
Correct. So that's what we have. All right. So D, look at what we have as D. This is the value of D. Now we use U. Please mute yourself. Let me not don't be distracting me. Don't be distracting
Mute your
me.
mic now.
Sir, just continue, sir. Just stop on.
Come, what is this nonsense now, eh? Can we just hear something?
Please mute your microphone.
Just Joshua, if you don't want to learn, please leave the class.
Sir, please,
Who is
those
this
who
woman
don't want to
being now?
learn, log
Who's that
them
person
out.
disturbing this class now? What sort of nonsense is this?
I will log the person out now. Let me find the person.
And why is it that difficult?
Once they let
If you don't want to learn,
log them out.
I wouldn't leave.
Anybody I see now that is not muted in this thing, I will log the person out quickly so that we can have peace. I'm trying to mute everybody. All right. Okay. Okay, so we will now use the above result can therefore be substituted into equation 4.8 below using u and x to calculate the x. I mean u and d to calculate the x. Actually, the d here should be a big D and x here should be a capital X. So we have u. This is 3 minus 2, 1. C minus 7 point. That's why I say correct that value is not 0. It's minus 7.3333, 4.667, and this one x1, x2, x3, and this is the modified d now, which is our d. So if you do back substitution, look at it. We can write out the equation so that I can do back substitution. So you have 3x1. 3 times x1 minus 2 times x2 plus 1 times x3 equals minus 10, the first equation. And then the second equation minus 7.333 times 0 times x1, that's 1, nothing here, minus 7.333 times x2 plus 4.667 times x3. Which will give us 50.6670. Then the last equation, no x1, no x2, so we have minus 5.3517, right? x3 equals minus 20.12010. So you do back substitution. x3, look at x3 now quickly. x3 is minus 20.120 over this, which is 3. And then you put the value of x3 into the second equation, right? So it will be minus 7.333 x2 plus, but it will be minus now because we have that. So you have 7 minus 7.333 x2 equals, right? This goes to minus that way, and this is the x3 we have calculated. We have x2 is minus 45749. Then you substitute x3 and x1 into the first equation. The method is 101 after we verify this thing. So this is x2 minus 22 point that's what we have here. x1, x2, x3.
Sir, this one I think is wrong, sir.
Yes. I can see that there are details. You just get the procedure and then calculate the correct things there. Do you understand? Just
Okay,
follow what we are doing and then get the correct, because I saw that up there was something wrong there, which we will correct. I'll look at it myself, then I'll correct. But the procedure is that you see how we decomposed from A to L and U. You see how we formulated U, L, very important, using F21, F31, F32, and the diagonal of L is 1, 1, 1. The rest is 0. This is very important. And then we want to calculate intermediate vector D. That intermediate vector D is the same thing as the D right-hand side modified. We will use lower matrix and the original B given to generate D1, D2, D3. And those D1, D2, D3 will correspond to B modified. And then we use the values of U and D to calculate X1, X2, X3. This is the major procedure for LU decomposition. Look at the equation which we resolved before. All right, we just want to show this example. That is the equation which we resolved before. All right, 10x1 plus 2x2 minus x equals 27 minus 3x1 minus 6x2 plus 2x equals minus 61.5. x1 plus x equals 5x3 equals minus 21.5. We want to use LU to do it. You can rewrite the equation and the numbers, they are all there. See, E, 4, 11, and so. So, we want to eliminate x1 from second equation, x1 from the third equation, leaving the first equation unaltered. So you see, F21 is A21 over A11, which is minus 3 over 10. That is F21. I want to tell you how we will formulate L. So that's why I'm doing. So when you multiply and you subtract from equation 2, you will eliminate X1. Then who is the person disturbing again? All right. So when you eliminate X1 along the first line, that's what you have here. Okay. You see 5.2 x2 minus 1.7 x equals 3.4, and then 1 minus 0.8 x2 minus 5.1 x3 equals 24.2. All right. Then again, we want to eliminate x2 from here. X2 from the third equation, leaving the second equation unaltered, but that's where we have our pivot value. So it will be minus 0.8 over 5.4. That will give us F32. You can see it. When we do that, we have a triangular matrix. This minus 5.4x2 is supposed to be under the 2x2 so that you can appreciate the upper triangular matrix. And this 1.7 x3 is supposed to be under x3 here, and this moves down to this place. So these are just rearrangement because of printing or something like that. But that is how it is done. 10x1 plus 2x2 minus x3 equals 27, and then minus 5.4x2 should be under 2x2, and then 1.7x3 should be under x3, and then minus 53.4 should be on the right hand side. So you can appreciate a triangle, right? So let's move ahead. We can now calculate the lower triangle. We have the upper triangle already here, and then this is the lower triangle. All the F21, F31, F32, they are all here. The values are all here. You calculate the values and put there. You can see one along the diagonal of L. The next thing we'll do is we want to generate the intermediate or intermediary value vector D generated with L and D.
Sir, please, how come about the zeros there? After the one,
zero?
yes.
Because we don't have anything on them now. We are talking about lower triangular matrix. The upper one is already here. The upper one is supposed to replace all these values here. You
Okay,
understand?
so how did you get the 0.1?
0, 0, 0, you know, those are the values that are supposed to have been here. Write a square. Draw a square somewhere there. Draw a square. And then join the upper point, the left upper point to the right lower point. You have two triangles. If you do it, you have two triangles. You have the upper one, I have the lower one. So the upper triangle, all these values you are seeing here, like this one's supposed to be 10, this one's supposed to be 2, this one's supposed to be minus 1. You understand? And
Yes,
this
sir.
one is supposed to be minus 5.4. This one's supposed to be 1.7, and this one's supposed to be 5.35 to make the triangle complete. I mean,
Yes. So
how
did
did
you get
this
this
minus 0.14815?
That is the factor here. See it?
Yeah.
This factor here. Divide minus 0.8 by 5.4. What do you have?
Minus 0.14815.
Correct, sir.
All right.
So you're correct. But this 0.1, how did you get it?
Okay.
0.1
The same way.
is
Yes.
1 over
1
10.
divided by 10.
This is, you are not following me, sir. I will say this is F31, which is 1 over 10. When you look at the general equation, how we eliminated x1 from it. See it?
Oh, okay.
You see it?
Okay. Yes, sir.
All right. So that's how we got that.
Okay.
So it's very important to know how to set up the lower triangular matrix. Very, very important. Okay? So when we finish this one now, please mute yourself, stop talking and listen. When we finish that one now, we will now use this triangle here, lower triangular matrix, to generate vector D with the original D given. Look at page 37. Look at it. So that's what we are doing. You see the first equation, see the second one, see the third one. This is the lower triangular matrix. We want to calculate D1, D2, D3. This D1, D2, 3 will be the modified D before.
Sorry, sir.
Let me finish. You will come. Let me finish. So
Okay, sir.
you can see. Well, let's write out the equation. The first one is D1, 1 times D1 plus 0 times D2 plus 0 times D3. So that's why I have D1 equals 27. All right. Then the next equation is minus 0.3 times D1 plus 1 times D2 plus 0 times D3, which is 0, will give us minus 61.5. The third equation is 0.1 times D1 minus 0.14815 times D2 plus 1 times D3 equals minus 21.5. If you start resolving those equations one by one, since D1 is 27, substitute D1 into this equation, you will have this. And then substitute D2 into the last equation, and D1, you will have minus 32.11121. So D is 27, 53.4 minus 32.1. This is the value of the D modified when we applied naive gas. All right, then what we do now with this value of D, we will use the upper triangle, the upper triangular matrix, to calculate x1, x2, x3. You see the equation here, U times we have 10 minutes to be logged out. So you have the upper triangular matrix. That upper triangular matrix will give you this equation, just like we did D, you see it's 10 times x1 plus 2 times x2 minus x3 equals 27. And you do this one for here, this x1 is 0, x2 minus that, x3 1.7 equals that, and x3 is this, but all these are 0, so you have 5.35185 times x3 equals this. When now this is upper triangular matrix, so we can have 5.353, see it from this equation here, x3 now is minus 32 divided by 5 is equal to 6. That's what we got in that problem, isn't it? So, and then we substitute x3 into the second equation. We will get 8. We get x2 equals 8. And then we substitute x3 and x2 into equation 1. If you do that, you will have that x1 is 0.5 like we did before. So LU is also another method to calculate the values of the unknown in a system of algebraic equation. We have done naive gas and we have done LU, all right? Please try to know how you can apply them by visiting those problems we have just looked at now and follow the procedure and see how you can get to those values. It's very important for you. All right? Let me briefly stop here and then let's use 7 minutes to ask questions. 7 minutes to ask questions. So if you want to ask a question, you unmute yourself and tell us your name so that we know who is talking and ask your question.
It's a question, sir.
Hello, sir. I just wanted to say that
What's your name, please?
Solomon, sir.
Salomon.
Solomon Ekolama, yes, sir. I just wanted to say that my page 37 is blank.
In your
My material.
Please come to the office tomorrow and get a copy.
Okay, sir.
Accept it to me. The same with me too.
The same with me.
Please check, please. I want to use this opportunity to say, please check through. You know, this
Does this LU method has over 9 costs? Because I understand we could have done some for the values of x1, x2, x3 when we got to the limit of where Gauss ended. But we still went further. We had to do the inverse of the triangular.
you see,
So what advantage does it have, sir?
you
Yes, sir.
see, this was a research done by somebody to tell us how we can calculate x1, x2 using system of equation. There are times bisection method may not work out. You will, when we start getting to some difficult problem, you see that bisection method may not work out. So we use LU to try and see if it can flow. So I don't think that whichever method that is put down for us to study is a waste of time. It's not. This is the method. This is the method. What are you trying to say?
I never meant them to play down on the process. I was just saying we are studying a lot of methods, so we need to know the advantage. Is it that we get one is more precise, or there are more effective way of?
Okay. You're almost on the same page with me.
All right.
We are just learning. That's why I said no knowledge is a waste. Whatever you have learned is still useful. The advantages are that. That's why I'm trying to say that there are situations where class elimination will not work well, and LU will just do it for you better, and you get the result you want because you will be doing practicals or doing mathematical modeling, and you need to resolve some of these equations. So you can use either there are stations where Gauss elimination may not work out. I'm telling you, there are such situations. So all of them, they have their advantages. You understand? So then we know
I want to ask a question, Janet.
Janet, Joshua, are you okay? Are you okay?
I'm okay, sir. I'm very okay, sir.
Okay,
Sir,
thank you, Janet.
I don't even have the
Okay,
material
sir.
able to get my homework.
Janet, go ahead.
So I want to ask the exercises that are associated with this chapter we just covered. They are not like the regular exercises. So I don't know. These ones, they look a bit different from the regular ones we have. So I don't know if you could throw more light on.
Let's see them now. Let's see those exercises.
No, the ones on the previous chapters.
Are you trying to say
Is
it's
the
not complex?
exercises associated with this topic on page 38 that you said we should try some? Yes.
Page 38. What is in page 38? Yes. Okay. Well, but are you looking at my screen that I'm sharing with you?
That means my screen and yes, my own page 38 and yours are not the same thing.
Of course, we are sharing page. That may not be the same thing in that one you are handling.
I will go to the
Except,
But my own has exercise.
let me go to the exercises.
Sir, it means you change 38 for us because it's like a program. It's like a control program.
Wait.
Control.
This is the exercises. Is it up?
Yes.
Are you seeing the exercises?
Yes, sir.
Okay. So, question 1.
Sir, no, one is that, sir. 38. 38 to start with.
Which
Sir, one, I would
What page are you at?
exercise.
That is where
Is that
page 38. Sir, that's what
This is our own page 38.
It's the same thing.
What page is it? Because it's a bit scattered here.
This is 38, sir. Where you are is 38.